This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM STEAM, and this is Solve It for Kids, the science podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. How excited are we that we get to talk about space? And this time, we are taking all of our student kids with us with a great challenge.
Yes, we are. And this is going to be really exciting. So what problem are we solving today?
How does NASA keep missions safe?
Ooh, how does NASA keep missions safe? This sounds not only cool, but very important. Yes, who is our guest today, Jeff?
Absolutely, and we have the right person to talk to. We have the awesome Lauren Clayman. She is Chief Safety and Mission Assurance Officer for NASA's Radioisotope Power Systems Program.
Welcome to the show, Lauren.
Thank you. I'm so excited to be here. Thanks for having me today.
Well, we are excited to have you, and we're going to talk about one of our favorite things, space. Okay, so my first question is, when you were a kid, did you always want to work for NASA and work with energy and safety?
I love this question. I always wish I had this amazing answer, but I feel like I have kind of an answer a lot of people tend to have, which I wanted to be an astronaut when I was a kid.
Oh, well, there you go.
Okay.
I want to go into space. I want to be one of NASA's astronauts. I want to maybe go to the moon, maybe go to Mars, certainly to the space station. And so that's really what kind of lit the fire in me to want to work for NASA. Clearly, I'm not an astronaut today, but my, my aspirations changed over time. And I still maintained throughout childhood sort of a love of math and science. I had some great teachers who really fostered that love for those things inside of me. And I had some opportunities when I was younger to, work as a cooperative education student while I was in college. And that's how I got my foot in the door at NASA Glenn Research Center.
That's so fun.
No
I love
kidding.
it.
So, in getting your foot in the door, do you kind of remember something about one of those very first or early programs that you worked on, something that really kept your interest and set you on this path?
Yeah, well, it's funny because when I was a cooperative education student, you're only working for about one semester's worth of time. And then you go back to school for a semester and then you return back. So you're just getting little snippets of the work. And we all know it takes years and years and years to put things into space. But when I was working, my mentors that I had and my boss, they put me on projects that were coming up with conceptual designs for things. So it's interesting. We'll talk about this later, but it was kind of cool because it was like the beginning of what people at NASA try to do to think of how could a mission work? Where do we want to go? What do we want to do? How do we want to do it? And I got to be part of that. And I thought that was so cool because it just kind of let my imagination run wild.
I love that you got into conceptual stuff. That is terrific. I can understand why you kept going with it.
Oh, yeah.
So with that, how did that translate into sort of a permanent job at NASA? Yeah, your title is super impressive, though it may need a little bit of explaining for our listeners. But what is a Chief Safety and Mission Assurance Officer?
Well, so there are lots of Chief Safety and Mission Assurance Officers working on many different NASA programs and projects. And
Okay.
in the simplest form, it's kind of boring. So we're responsible to make sure that we're doing things safely. I mean, really, it's that straightforward. We want to make sure that we're doing things safely, like meeting safety requirements, following processes
Right.
and planning and evaluating situations where we might need to deviate from what the original plan was. So we have to ensure that we're
Okay.
looking at all of our options, that
Right.
we're understanding the risk of deviating from the original plan, and then being able to justify that. But what's cool is that even though we have lots of different chief safety and mission assurance officers working on the various NASA programs and projects that we all get to exercise our own personal responsibilities for those programs and projects a little differently. And
Nice.
yes, and I think that's where it's really cool. I didn't start off in working in the safety area at NASA.
Oh,
I
okay.
started off doing engineering, analysis, design work, testing in laboratories and vacuum
Okay.
chambers. And I thought the safety aspect was very, very interesting because if you don't have safety, you don't have anything. I like to say that it's
Right.
not an
Sure.
afterthought, it's the first thought at NASA. So I was very intrigued by all of the details that went into making sure things were safe and that missions were also not just safe, but we're going to perform as expected, because that's another aspect. Once you got safety checked, you make sure that now you're going to have a successful mission as well. So that's part of sort of
Nice.
we lump in that whole chief safety and mission assurance officer element. The mission assurance is making sure our missions perform as planned.
Well, I mean, that's great. And that kind of answers our question, how does NASA keep missions safe? But can you talk specifically about the program you work on and how you're working to keep some safety on that mission?
Yeah, absolutely. I'll probably start, if you don't mind, just sort of explaining what radioisotope power
That would
is.
be great. Yes.
So yeah,
Perfect.
so working for the Radioisotope Power Systems program, we call it RPS for short. It's a mouthful. So these systems use the radioactive decay of a material called plutonium 238, which it's basically giving off heat constantly. And
Right.
that heat emission is harnessed and converted into electrical energy. And it's all done through this RPS, radioisotope power system. And so, because it's a nuclear material, obviously there's a safety aspect that comes
Yes.
with that, right? Um,
Yes.
Absolutely.
and it's an alpha emitter, so it's an ionizing radiation. The good news is that this type of radiation, in this case, it only travels a few inches in air. It's very safe to
Oh,
be
okay.
around. It can be blocked by skin, clothing, even a sheet of paper. The thing is, you do not want to inhale or ingest the material. And so, for that reason, we control the way it's produced. It's produced in a
Right.
ceramic form. And so, if it's going to break, it's going to break kind of like dropping a coffee mug. It'll break in chunks. It helps
Oh, okay.
make sure it's not.
Right. Right.
Yes. So that way it can't be inhaled. It's not soluble in water and it can't mix well with other chemicals. So safety starts at the core of how it's produced. And then on top of that, I won't go into too much detail, but this ceramic material is about the size of like a marshmallow.
I was
And
going
it
to
gets,
ask you how big it
yeah,
is. So that
yeah.
little tiny size can actually produce a huge amount of energy?
Well, it produces a lot, but we actually stack a whole bunch of these marshmallow sized pellets, we call them. First, we layer them up. So we layer them in like a metal alloy. And
Okay.
then on top of that, there's a bunch of layers of like heat and impact resistant material. And
Okay.
Okay.
finally, they're put into this ruggedized box. So the entire thing has about 4 of these pellets in it.
Oh,
And it's
wow.
called a general purpose heat source. And again, of course, we're NASA, so we give it an acronym, general purpose heat source,
Yes.
GPHS. And
Okay.
we take these boxes that have about 4 of these marshmallow sized pellets in them, and we can
Okay.
stack these boxes in the center of a radioisotope power system. So
Oh,
it will be a lot more than 4 pellets. It's usually about 8 of these GPHSs stacked together, or up to
Okay.
16. So 8 to 16 of them times 4. Yeah, and so they do give off a lot of heat, but the interesting part is we have a lot of waste heat because the way we convert the thermal energy into electrical energy is not very efficient. So there is waste
Right.
heat. We have to radiate a lot of the waste heat off, but this is how we can travel so far because we have this source that continuously generates heat through radioactive decay. And it's like a continuous source, unlike a lot of the other things that you're used to hearing about. Solar panels
right.
are great, they only get you so far. Batteries are great,
Okay.
but they run
Yep.
out. They
And
get
only
cold,
the
don't
solar
work.
panels only work if you're positioned towards the sun too,
Oh,
which you
right.
always
Right.
control with the spacecraft, right? Like where it's going.
Absolutely. That's a factor. So you have to make sure you can, number one, face the sun. And number two, obviously, the farther you get from the sun, the less intense that energy is. And so you're going to need a gigantic um, solar array or solar panel when you're far from the sun. And that's just not practical. So these
Right,
systems
right.
enable us to go very far when the sun is no longer powerful enough or batteries cannot last or cannot stay warm enough. So this is pretty much one of the only solutions for that long-term power for those deep dark places in our solar system. But like I said,
Okay.
safety is important. And the reason why that's important for my job is number one, we build this into the design from the get-go.
Right.
And then
Right.
with all the partners we work with for our missions, we have this now really ruggedized nuclear material, and we very carefully ensure that we understand what type of launch vehicle this is going to be flown on, where it's flying
Okay.
from, what's going to be on board with it. And we don't like to want to have to think about a bad day, but we plan for that all the time for any NASA launch.
Oh, sure.
And
Right.
so we understand all those things. We run a whole bunch of analysis and we figure out the ways in which this could possibly, affect the public on a bad day. And we will not launch anything that has too high of a risk threshold. So there's obviously exposure limits,
Right.
and amount of material
Right.
limits to people. And so we have those thresholds and we cannot go over those when it comes to launching and coming up with
Well, that's
what
good
might
to
happen on a bad day. Yeah. We take it
Yes.
very seriously. I mean, it's an important thing.
Okay. So just to get a little bit more specific, because it will play into the challenge we're going to talk about soon. When you were describing, two questions really quickly, the marshmallows, are they mini marshmallows or the bigger ones? Just to have an idea of what that 4 cube looks like. And then when you said you build the little power system around it, could you
Mhm.
give us and then you stack those together,
Mhm.
could you give us approximate dimensions on how big a single one is?
or
Yeah.
like what it looks like, compared to something
Yeah.
you would know or people would
Oh,
know.
for sure. So the marshmallows, they're not the mini marshmallows. I'd say the regular marshmallows.
Okay.
The ones
Okay.
you roast over the fire easily, on a stick.
Yes.
And when you stack these, it's almost like these radioisotope power systems are a cylinder, half a meter high
Okay.
or
Okay.
so. And they have spokes coming off, like you'd see spokes on a wheel. They're
Okay.
flat spokes. And so those are the radiator panels that I was talking about, how this material, the nuclear material, actually produces more heat than can be,
Right.
turned into electrical
Okay.
energy. So that's how we get rid of the extra heat, is through those radiator panels that are coming off. And there is, we've got a website for all things related to radioisotope power systems. It's nasa.gov/RPS. Very easy.
Okay.
Okay.
There are some really cool animations that show not only what I explained earlier with the pellets for the nuclear material and how they're
Right,
encased.
right.
There's a really cool
Right.
animation that shows that. And there's also a good depiction of what this whole thing looks like. So a cylindrical sized thing, no taller than like a half a meter or so, with these
Right.
spokes coming out of it. It shows you how the whole thing comes together.
This is
Nice.
so amazing. And these can be put into spacecraft and we can send them way, way, way out in space, which I think is incredible. But now, even though we usually keep our challenges to the end of the show, we have such an exciting challenge here that NASA is offering for kids that, Lauren, we were wondering if you could tell us about that.
Yes, I'm so excited to talk about this challenge. This is for students, grade school students, all the way from kindergarten through 12th grade in the United States.
Wow. Super.
Of course, we want them to learn more about radioisotope power systems, but it's more for them to just have fun. They've got nothing to lose. We want them to write a 275-word essay or less, which isn't
Mhm.
that long, actually. It's like a paragraph or two.
Okay.
We want to hear where they would send a mission that would be powered by an RPS to any moon in the solar system that they would choose.
Wow.
Yeah, and there are a lot of
Alright.
moons in the solar system. There's
A moon. I like that.
there's 750 moons in our solar system or something like that. They don't all have as cool names as like Enceladus or Titan or Io, but it's almost limitless. So they would, in this essay, want to tell us where they would go, what they would explore, and really how they'd use that power coming from the RPS to do their exploration. And one
Okay.
other aspect of this essay is we want to make it even more fun for them and make it personal. We want to hear about what they believe their own unique superpower is and how that would help them achieve mission success.
Oh, now that sounds fun.
What a great addition. That sounds kind of a lot like working at NASA, because just like yourself, the folks that work at NASA that are building these missions, you are bringing all of your special talents in to create those missions to expand what we can do and where we can go explore.
Yes, that's exactly it. That's exactly it. Everybody brings something unique to the table. Everyone thinks creatively. And so what is that one thing about, each student that would help them, something that they can feel proud of and want to talk about? It could be a challenge that they've overcome in their life, or something that they're really, really good at, or something they weren't good at and they overcame it. So we want to hear all about that as well.
Once you get these essays, are they going to be read by people? And then is there like a contest and all that kind of stuff too?
Yes. So these are all due the end of January 31st, 2025. Okay. And there are a bunch of judges that will go through all of the entries and read all of them. And I mentioned it's for K through 12. So it's the different categories are chunked into age groups from kindergarten through 4th, then 5th through 8th, and then 9th through 12th. Okay. So within each category, there will be some different winners. So 15 semifinalists will be chosen from each grade category that I just mentioned for a total of 45, and they will all receive a NASA prize pack.
Oh, that's awesome.
Wow.
I know, isn't that cool? So
45. That's
45
that already
total.
Signs kids up, because it's not just one. Well, if I don't win the whole thing, then I'll get 45. That's wonderful.
Yeah, that's fantastic. And then from those semifinalists, 3 finalists from each grade category will be picked. And each of those, so 9 total, will receive a virtual session with a NASA expert.
Oh, wow.
Yeah, I've had the pleasure of talking with some of those students before in the past from previous contests, and it's a lot of fun. Really great questions, and I love interacting with these students.
Yeah. I'm sure you get tons of great questions, because when I go and talk to students, and so does Jeff, I mean, kids, they're really smart. And they ask you some questions that, I don't know about you, but they stump me sometimes, right? Like, I'm like, I don't have the answer to that, but let's go look it up, right?
I know. I always try to tell them, hey, listen, don't be afraid to ask me questions. I'm afraid I'm not going to be able to answer your question, or that you're not going to, like what I have to say. I'm probably more intimidated talking to these students because they are so sharp, than they should be talking to anyone. So it's a lot of fun. I always try to let them know that, don't hold back, ask anything that you want to.
Right.
It's a good time to have that dialogue. From those 3 semifinalists in each grade category, there will be 1 grand prize winner from each category. So those 3 grand prize winners will get to come to NASA's Glenn Research Center in Cleveland, Ohio. And they'll visit here, they'll get some tours, and get to talk to some more engineers and folks that work at Glenn.
Do you have any tips for them on how they may keep their essay and their idea succinct and short enough to fully get that idea across to NASA?
Oh gosh. Yeah, no, you hit probably the biggest challenge, because once they get going, it might be hard to stop, because they might have a lot to say. It goes quickly. 275 words is actually a paragraph or 2. What I would say is just state from the get-go, where your destination is that you would use for your RPS, and then only talk about, the basics of what you want to do there and how you're planning to do it. And of course, don't forget your superpower. So just hit on those 3 things, but have as much fun with it as you can, and, be as creative as you can. But yeah, it won't be as hard as you think, because 275 words isn't that much.
No.
All right.
Speaking as someone who writes books for a living and also writes picture books, 275 words is very tough to be very succinct in, but you guys can do it. Now, how do they enter the contest, and where do they send all this?
So this is all available on our website, and I don't want to misspeak about anything. There is even a video that talks about it. So it will be an online submission. I don't have any specific URL. So if you visit the nasa.gov/RPS, everything will be there related to the contest.
Perfect. That's good to know. And you know what I love about this is kind of as we were talking, it's creative and you don't have to be like a science kid or an engineer kid or understand all of those things to enter this contest, right? You could just be a writer who imagines all of these different things. It can be a really creative endeavor. I think that's what you're going for, right?
Right, right. That's you hit that also right on the head is I'm so when I read these, I've been a judge before for these essays and I am shocked because I can't believe that some of these people, how creative that they are, these students, their minds are just working almost more creatively than what I've seen at NASA before. I just can't believe that they're thinking this way. They're thinking about things that I know are already conceptually being thought of by people at NASA. And I love seeing that parallel there.
Oh, that's fantastic.
Hmm.
That really is. With this, I sort of want to go in a slightly different direction, is because Jennifer just mentioned it. But for you, Lauren, not that you want to spur, because you're not the judges for this. So, kids, you guys, students, you write about whichever moon piques your interest out there in the solar system. But, Lauren, if you were going to explore somewhere out in the solar system with a radioisotope power system, where would you go explore?
Oh gosh. And this is going to sound terrible because we already have a mission going here, but Titan, Saturn's moon Titan, is so
Okay.
interesting to me. And it just so happens that the Dragonfly mission will be going there in just over 4 years. And yes, they're going to be sent. The Dragonfly mission is sending up what's known as a rotocraft. So it's not like the traditional rover with wheels that you know that NASA sent quite a few up to Mars before.
Right.
We're sending a
Right.
rotocraft to Saturn's moon Titan to explore Titan because it has an atmosphere. It can fly around and it's going to actually enable a lot more traversing over the surface of this moon. But what I think is
Sure.
so cool about this moon is that it has an atmosphere. It's an
Yes.
ocean world and it has this nitrogen and methane atmosphere. It's not exactly like Earth, but there's weather there. And so scientists want to go, oh my gosh, let's go study this because it seems to kind of mimic the way that Earth was before life existed here. And so we want to go, okay, this is
Okay.
like the precursor. Could there be some of these things that we're learning about, in a world pre life? But it's going to be so interesting. This rotocraft will collect samples and study the composition of the materials. And so, despite the fact that we already have a mission going there, I am very, very intrigued by this moon.
I like
Yeah.
that.
I mean, I think there's so many different ones to choose. I happen to be at the Europa Clipper launch. So right now I'm passionate about everything Europa
Oh, that's
because
amazing.
this just is fascinates me what we could possibly find on Europa and how it all relates back to our Earth. And so the other thing I'm really loving right now is astrobiology, which is, the search for habitats that might, have life in some form, right? Like even if it's
Mhm.
tiny little microbes or something like that. And so I think everything NASA's doing with this to send all these out there is really cool. And, to think that it's all made possible because of radioisotope power is pretty cool when you think about it, right?
Oh, yeah. Yeah, I know we couldn't go as far as we've gone. And if you think about the Voyager missions, if you're familiar with those,
Right.
from the
Right.
70s, they are still going and they're powered by radioisotope power systems. And they've flown by a bunch of moons as well. I mean, they gave
Yes.
us some of the earliest information about some moons that, NASA's very interested in. And it's like we wouldn't have gone there if we didn't have this constant power source that enabled us to go this far. We can't do it with traditional batteries that we send into space for other things. Can't do it
Right.
with solar panels, but it's pretty amazing how far these things can go.
Oh, yeah, absolutely.
Are there any limitations where there's a place in the solar system that we wouldn't be able to get to?
Oh, wow. I honestly think the limitations come down to can we get there if we're trying to get somewhere and, orbit
Mm,
a planet or a moon? That doesn't seem to have
Oh,
as many
okay.
limitations as like landing somewhere, right? So I don't think there's a limitation to landing places unless you're trying to take a radioisotope power system there to provide you power for wherever you're landing. But your lander has to then be able to, you know, endure the environment that it's going to. I mean, these moons, they are some of them are icy. The temperatures drop, unfathomably cold. They're dusty. And so you have to factor in all those types of things into the survivability of your whole spacecraft. Will the dust get into the wrong crevices? Will it affect the mechanical components? So I think theoretically we could take them anywhere. Because they're going to give off power no matter where they go, but it's a matter of how harsh is the rest of the environment and how does that play into the rest of the spacecraft's operability.
And then, just like you said before, thinking about all of those pieces together as that mission is being created and built. Yeah, that's a lot of moving parts.
Oh, yeah. Yes, it is.
That definitely is. Oh my gosh, we've learned so much about safety and how NASA focuses on all of that for all of its missions, radioisotope power, all of these different things. Can you remind everybody one more time where they can find out about all of this information and the challenge that you told us about, Lauren?
Yes, please go visit nasa.gov/RPS.
Oh my gosh. I hope a lot of you decide to do that. We will also have all of the information on our website, solveitforkids.com. But this has been such a fabulous conversation.
Yes.
Thank you for being on Solve It for Kids, Lauren.
Thank you, Lauren.
Thank you. I had so much fun today.
What a very fun chat with Lauren. A great way to describe radioisotope power in those marshmallow chunks. I can absolutely picture it. And it just makes me want to learn more about how they have already used some of those, but then talking about that challenge, which jumps us into future missions. What do you think, Jen?
Yeah, I thought it was really great. I always, you know me, I write books for kids. I love analogies where you can immediately understand the science or envision the size of it. So she did a fabulous job. But I think radioisotope power is so cool. Think about we talked about that, all of the amazing places in our solar system and possibly beyond that we can visit with this. And so, I don't know about you, but I wish I could do this really cool challenge.
I totally do. Ever since she mentioned what it is, specifically writing an essay, 275 words or less, about which particular moon in the solar system. I love that NASA chose not planets this time because, as Lauren said, there are so many moons in our solar system. And they have such diverse ecosystems and characteristics, and they're all throughout the solar system that every student gets to pick where they think would be the most interesting. And this radioisotope power system can take their spacecraft there to do the exploring that's in their imaginations. I love this one.
I do too. I think it's really creative because you could decide to go kind of geek out on learn about a particular moon that maybe nobody else knows about and all this kind of stuff and highlight that one in yours. And then you get to create your own superpower. Come on. This sounds so amazing.
And putting those two together to go explore the solar system.
Yeah. Exactly. That would just be fun. So we hope all of you check out nasa.gov/RPS, the website, and find out all about the contest and how you enter it. You should do that soon because the entries are due at the end of January in 2025. We will also have information on our website, solveitforkids.com, which will direct you over there too. And some cool pictures because NASA always gives us some cool pictures that we can put on our website. If you enter or you want to share what your superpower is with us, you can find us on social media. We are at KidsSolve at Facebook, X, and Instagram. And again, make sure you check out our website, solveitforkids.com, where we have lots of information, not just about this episode, but about all of our episodes. So you can go back and see how many times we've talked to NASA about a lot of the cool missions they have done.
So don't waste any time. As soon as you click off finishing this episode, start your challenge. Start thinking about it right now. You heard in this episode, Lauren's favorite would be Titan. Jennifer's favorite would be Europa. Jeff's favorite would probably be one of the Galilean moons of Jupiter. I've got to pick my favorite before I go. but we want you to do this challenge. So get on to nasa.gov/RPX. Until next time, you'll hear Jen and Jeff on the science podcast for kids and families. Solve it for kids.